So we're going to be going through the Precalculus Semester 2 exam review. We're going to be going through all the questions covered in the exam, and we're going to use these formulas as reference. These will be provided on the actual exam. And what you see that there is a lot of trig functions, including the law of sines and law of cosines, including a few conics equations down here at the bottom. So each video is going to be comprised of a small set of questions comprised into columns. So without further ado, we're going to jump into the first column. Okay. So question 1. Okay. We want to find the distance AB across a river. If distance AC of 738 meters is laid off on one side of the river, it is found that A is 108 degrees and C is 17 degrees. Find the distance across the river from A to B. So we want to find the distance from A to B. So we're assuming A to B is across the river. We know distance AC is 783 meters is laid off on one side of the river. So I know if this is the river, right here, AC is laid off on one side, which means I have point C down here. I know AC is 783 meters. I know that A is 108 degrees. So I know that this is 108 degrees. And C is 17 degrees. So I'm going to go ahead and connect this third point and say this is 17 degrees. So I want to find the distance across the river from A to B. So let's go ahead and translate this without the river at this point and take a look at the triangle that we have. Not really sure where that ink came from, but I have this triangle right here. I have A, B, C, 783, 108, and 17. And I want to find this distance x. So what we're going to be doing is we're going to be using the law of sines. On our formula sheet, we have the sine of A over A is equal to the sine of B over B, which is equal to the sine of C over C. So what I have right here is I have two angles of a triangle. What I can use is I could use that to infer the third angle of a triangle. I know all angles A plus B plus C must equal 180 degrees. I know if angle A is 108, let's rewrite that as 108. If I know angle C is 17, then I can use that to figure out what angle B is. So 108 plus 17 is going to give me 115, 125, plus B is 180. If I subtract 125 from that, I will get B is equal to, let's see, that would be 80, 60, 55 degrees. Okay? So now that I know angle B is 55 degrees, I'm going to use that law of sines to figure out what my value for x is. So A over A is equal to B over B, C over C. So I'm going to say my sine, let's do this right here. So the sine of 17 degrees over x is equal to the sine of 55 degrees over 783 is equal to the sine of 108 degrees over whatever BC is. So given that information right there, I know that I'm trying to find x. This has an unknown in it, so I'm going to be ignoring that relationship. I'm going to focus on these two, and I'm going to solve for x. So with this, all I'm going to do is I'm going to cross multiply. So I have x sine 55 equals 783 sine 17. To isolate the x, I'm going to divide both sides by the sine of 55. So x equals 783 sine 17 over sine 55. And I'm going to use that. Let's see, do we need to round to the nearest degree? Nope, it doesn't say anything about that. So I'm going to go ahead and I'm going to pull out my calculator and I'm going to say, okay, numerator, what is 783 times the sine of 17 divided by denominator, the sine of 55, close denominator. Now, before I hit enter, one of the big things I want to check is I want to check to make sure I'm in the right mode. My calculator is in degrees, so we're good to go. So boom, this is going to give me x is equivalent to 279.468 meters. I believe the original question was in meters. Yes. So 279.468 meters. When we don't know what decimal to round to, if we can produce an exact answer, let's do it. Otherwise, let's always round to the third decimal place. Awesome. So that was question 1. Let's take a look at question number 2. Okay. So question number 2, Sasha's outside of a building. She sees Thomas on the 4th floor at an angle of elevation. So right now what we've got going on is we know Sasha is down here, and she's looking at Thomas on the 4th floor of a building. So let's say this is a building, and here's Thomas. Hello. She sees him at an angle of elevation of 48 degrees. So when she's looking at Thomas, she's creating an angle of 48 degrees. She then sees Sebastian on the 9th floor at an angle of 67 degrees. So, my drawing, I should have drawn a little more room. Let's say this is now the 9th floor. She sees him at an angle of 67 degrees. So this whole thing is 67 degrees. If Thomas is 52 feet from ground level, what is the distance from Thomas to Sebastian? Oh, okay, so this is Thomas, and this is Sebastian, and this is Sasha. Okay. So Thomas is 52 feet from ground level, so if this distance right here, so I'm going to do this in red to differentiate, if that distance is 52, what is the distance from Thomas to Sebastian? So we're trying to find this distance right there. Okay. So what we're going to have to do is I'm going to draw 1, maybe 2, possibly 2 smaller triangles. I'm going to break these 2 triangles apart. So we're trying to find that length right there. So what I'm going to do is I'm going to take that lower triangle between Sasha and Thomas, and I'm going to draw it out. I know this is 48. I know this is 52. And this is 90 degrees. Then I'm going to draw this upper triangle up here. So I've got this triangle right here. And if this is 48 degrees and this whole thing is 67, this little spot right here is going to be the difference between 67 and 48. And the difference between 67 and 48 is 19 degrees. Okay? And I want to find out what x is. Again, I should have left myself more vertical space, but didn't necessarily think ahead. Okay. So what we're going to need to figure out is we're going to need to figure out what this shared leg is first off. Because that's going to be our clue to figuring out what x is finding that shared leg. So my first goal is to figure out what is that leg. I'm going to use 48 and 52. With so, ka, toa, I know to find out what this angle is going to be the opposite over the hypotenuse. I'm going to be using sine. So I know that the sine of 48 degrees is equal to the opposite over the hypotenuse, which we're going to call the hypotenuse. Let's call this, we don't want to call it t. I guess we could call it t. Let's call it little t because it's the distance to Thomas. So the distance over little t. Okay. So if I want to solve for little t, I'm going to multiply both sides by little t. So I get little t times the sine of 48 degrees is 52. And then I'm going to divide by the sine of 48. So little t is 52 divided by the sine of 48. Okay. It's going to give me Thomas's, or the length to Thomas. Now, I'm going to store this value in my calculator, but I'm going to round it out to the nearest decimal just to make things a little easier to write down. So let's clear this numerator, 52 divided by denominator, the sine of 48. I'm also going to double check I am in degrees. I always want to get in a habit of double checking that. and I get this decimal. So I know this is roughly 69.97. So this is little t. I'm going to store that so that I keep this exact decimal by hitting store. And unfortunately, I don't have little t in my calculator, so I'm going to store that as t. Okay. I know which variable I've stored in my calculator. I've got that right there. So on the triangle that I'm focusing on, this triangle right here, I know that this is roughly 69.97, I believe it was meters. Where are we looking at? We're looking at feet, 69.97 feet. Okay, so I've got something to go on. I know if I want to use the law of sines, I need another angle measure. So I'm going to need to figure out what that angle is. Well, that's not too hard to figure out because I know that this straight line right here is 180 degrees. If I can figure out what this part of this angle is, I can subtract 180 from that and get this angle. So in the lower triangle, I'm going to do exactly that. I know 48 plus this angle right here, let's call this angle, just angle A, plus the 90 degrees is equal to 180 because the sum of all three angles in here is equal to 180 degrees. 48 plus 190 is 138. Subtract that. A is equal to, let's see, that would be 80, 50, 42 degrees. So that is 42 degrees. I know that this angle is 180 minus the 42. So I take 180 and subtract 42, that'll give me 140, 138. Okay, so I have 138 degrees. So if I have 19 and 138, I can figure out what that angle is, again, using this same logic. So I'm going to double up. I'm going to say 19 plus 138 plus, let's call this B just for something different, is 180. 19 plus 138 is going to give me 148, 157. Subtract 157, and I'll get B is equal to, let's see, that's 80, 30, 23. So I have 23 degrees right here. Okay. Now on this triangle, that's all I need. I can use the law of sines officially. So let's zoom out just a tad. And I'm going to redraw this right here. Okay. So I'm at 69.97. I have 19. I have 23. I have 138. And I want to find x. One of the law of sines says that the sine of 23 over 69.97 is equal to the sine of 138 over, let's see, this is Sebastian, because it's the length to Sebastian, is equal to the sine of 19 over x. Okay? I have my known, in this case. I have my known value. I have my unknown value, the part that I'm going to ignore, and I have my desired value. So I'm going to relate these two equal to each other and solve for x. So I'm going to cross multiply. X sine 23 is equal to 69.97 sine 19 divided by the sine of 23. And this is going to be the length of x. And this is the value that I'm going to be using. So x is equivalent to, let's go ahead and plug this in. Remember, I have my 69.97. I'm going to use this long decimal instead of my abbreviated one. So numerator, I have alpha t times the sine of 19 degrees, close my numerator, divided by denominator, sine of 23, close denominator. Boom. I have roughly 58.303 feet. Awesome. So I know just by working through all the known values of my triangles, I drew my two overlapping, I split them into two, I found out all the information I could on this one that would directly relate onto the information in this one, which allowed me to use law of sines to get to my answer. They didn't ask for a specific decimal place, so I automatically rounded to 3. Okay. That's the end of question 2. Let's take a quick look at question 3. Okay. So question 3, as we work this out, we have a baseball player in center field that is approximately 330 feet from a television camera that is behind home plate. Okay. A batter hits a fly ball, it goes up to the wall 420 feet from the camera. The camera turns 8 degrees to follow the play. Okay, so what we got going on is we have a camera and we have a pitcher and we have a fly ball that goes to the 420-foot marker, which we assume is going to be the end point right here. And so the camera was focused here. The ball was hit all the way over there. We know that is 420 feet, and it had to turn 8 degrees. Awesome. So this is a really skinny picture of what is going on. Oh, hold on, we have one more piece of information. Baseball player in center field is approximately 330 feet from the television camera. So now this is 330. Not the pitcher, he's way back here actually. So let's redraw this a little bit bigger so we can have some more room, but we see the idea of what's going on. So I'm going to scale this and say this is 330, this is 420, and this is 8. All I did was I made it a little bigger. It's not necessarily drawn to scale. And what was the question asking? Approximately how far goes the center field have to run to make the catch? We're going to assume they're asking how far would that center field have to run. So we're looking at finding this distance because he's got to run all the way back there to catch the ball. We teach math, sometimes language is in our best suit. Okay, so this is all the information we need to know. This is, again, a perfect use for law of sines. I know that in this case, let's see, if we have 8 degrees, maybe not law of sines, this might be best for law of cosines. So the law of cosines states that if I have 3 values and I have 1 angle, that's all that I need to do this. So I have side 1, 2, 3, and angle 1. I can use the law of cosines. So if we denotate the angle and the length right here as A's, this is B and C. Okay. So I know it's going to be A squared equals B squared plus C squared minus 2BC cosine of A. Okay. So my length is going to be length x, so I have x squared is b squared, which is 330 squared, plus 420 squared, minus 2 times b times c times the cosine of a, cosine of the angle opposite that other leg. So times the cosine of 8 degrees. And we're solving this, and this will immediately spit out our length. So let's start figuring out what we got here. Okay. So I have 330 squared plus 420 squared. We're going to combine this into one go here. So we have 285, 300 minus, multiply all this together, so 2 times 330 times 420 is 277, 200 times the cosine of 8. We get that. And then what I'm going to do is I'm going to square root the whole thing. So x equals the square root of all of this. and I'm going to go ahead and immediately plug this all into a calculator all at once. So we have the square root of 285, 300 minus 277, 200 times the cosine of 8 degrees. Double check my mode before I hit enter. I am in degrees. Good job. Hit enter. He's going to have to run roughly 108.911, which is going to round that up to a 2. How far are we using? We're using feet. He's going to have to run roughly 108.912 feet. There we go. That's number 3. Let's take a look at the last one, number 4. Okay. Number 4, Tampa is 86 miles from Orlando. Orlando is 244 miles from Miami. And Miami is 295 miles from Tampa. At Orlando, what is the angle from Tampa to Miami? Okay, so we here in Florida know that Tampa is roughly over here, Orlando is roughly over here, and Miami, way down south, is down there. Okay. We know Tampa to Orlando is 86 miles. Orlando to Miami is 244 miles. And we know Miami to Tampa is 295. We want to find at Orlando, what is the angle between the two cities? So what we're trying to find is what is x. Now, if we had another known angle measure, I could use law of sines. So because I don't have that known angle measure, this is going to be the law of cosines again. And we just did the law of cosines. So we said it is a squared equals b squared plus c squared minus 2bc cosine of a. Okay. So what we're going to do is we're going to classify our a as this. This is our a values. So a squared is 295 squared is 86 squared plus 244 squared minus 2 times 86 times 244 times the cosine of x. Awesome. So we just have to solve this right here, and we're solving for the cosine of x. And because I have all these constants over here, to isolate the x, I know that we're going to have to use the inverse trig function. Well, let's go ahead and simplify as much as we can to start. Okay, clear all this. 295 squared is 87,025. 86 squared plus 244 squared gives me 2 times 86 times 244 is 41968 cosine of x. First step is I'm going to subtract that. So 87,025 minus 66,932. Next thing is I'm going to divide. So I'm dividing that by 4968. And I get that weird decimal. So that is, can I leave that as a fraction? It's just going to be that fraction. Okay. And we know to get the x out of the cosine, in order to type this into the calculator, is I just use the inverse trig function. So this will become the inverse cosine is equal to x, and x is going to give me my value. Now, in the case of us, I'm going to check my mode. It's going to give us our value in degrees. It doesn't ask degrees or radians, so you can give either answer, but for us, we're going to put our answer in degrees. So I'm going to be dealing with the inverse cosine, so second cosine, which gives me the inverse cosine of that fraction. So negative 20,093 divided by 4968. Okay, so what I had done is the 2 times 86 times 244 is 41,968. I neglected to write down the 1, which is going to drastically change my value. When I try and type that in, I'm going to type in second cosine of negative 20,093 divided by 41,968. And let's close that bracket. And we get an angle roughly of 118.605 degrees. That is the angle in Orlando looking from Tampa to Miami. And there we go.